Okay, so the next section in continuation of the previous is ongoing series of readings. This will now deal with data science and data engineering, data collection and pre-processing. So within data science and engineering, we have data collection and pre-processing, which means gathering data and preparing it for analysis. Then feature engineering, very important, selecting the most important data to use. Data visualization, creating visual representations of data like charts and graphs. Then we have big data technologies where we have Hadoop, which is a framework for storing and processing big data. Okay. Then we have Spark, which is a system for fast processing of large data sets. Then we have database systems, SQL and NoSQL databases, systems to store and retrieve data. Then data warehousing, which is collecting and managing data from different sources. Collecting and managing data from different sources. Then we have benchmark datasets and competitions, important topic in AI, where we have image datasets. Then in image datasets, we have MNIST, handwritten digits used for testing image recognition. Then we have CIFAR 10 by 100, which are small images for testing object recognition. Then we have ImageNet, which is a large data set of labeled images. It is having labeled images. And then a dataset COCO for object detection and segmentation. So COCO, ImageNet, CIFAR, MNIST, these are datasets used for benchmarking, analyzing the performance, that is finding out at what level the performance of AI algorithm model is. So then text datasets, IMDb reviews, some movie reviews used for sentiment analysis, Wikipedia corpus, Common Crawl, very important. Common Crawl. Then we have speech and audio datasets, Libri speech, audiobooks used for speech recognition. Then we have speech recordings used for research, TIMIT. Then we have reinforcement learning environments, OpenAI Gym, a toolkit for developing and comparing reinforcement learning algorithms. Then DeepMind Control Suite, environments for testing reinforcement learning. So OpenAI Gym and DeepMind Control Suite. Then we have competitions, AI competitions, which are Kaggle competitions, very famous. Challenges where people compete to solve data problems. ImageNet large scale visual recognition challenge, an annual competition for image recognition. Then DARPA challenges, competitions for advanced technology, and Netflix prize to improve movie recommendation algorithms. Then AI organizations and conferences. Organizations OpenAI, DeepMind, which is famous for AlphaGo, FAIR, Facebook AI Research, Google Brain, these are merged. IBM Watson, this was very famous initially, right now it's not so much in the news. Microsoft Research. Then academic institution famous for AI, MIT, Computer Science and AI Lab, Stanford, Carnegie Mellon. Conferences, famous conferences where you can publish your papers. Please keep these few conferences names in mind. Neuro IPS, ICML, ICLR, Triple AI, CVPR, SEL. So these conferences, keep in mind, none of them you should forget. Then emerging trends and directions and future directions. Here we have artificial general intelligence, AI that can understand, learn, and apply knowledge broadly like a human. Understand, learn, and apply broadly. Explainable AI, AI that can explain its decisions in a way humans can understand. Ethical AI, developing AI responsibly, considering moral principles. And quantum machine learning, applying quantum computing to machine learning. Then Edge AI and on-device AI, running AI algorithms on devices like smartphones. Federated learning, training AI using data from multiple sources without sharing the data itself. Federated learning, training AI using data from multiple sources without sharing the data itself. Training AI using data from multiple sources without sharing the data itself. Federated learning, using data from multiple sources without sharing the data itself. Without sharing the data itself. It's very interesting. Sharing the data itself. Continual learning. AI that can learn new things without forgetting old ones. Continual learning AI that can learn new things without forgetting old ones. This is very, very important. Extremely important. Extremely important. Then there is self supervised learning, learning from data without explicit levels. So, very, very important. Very, very interesting. Then causal inference, understanding cause and effect in data. This is also interesting. AI in Internet of Things, combining AI with connected devices. AIoT. Create synthetic data generation. This is also very important. So, creating artificial data for training AI models. So, now AI in global context, AI for climate change, using AI to monitor and combat environmental issues. AI in developing countries, applying AI to improve conditions in less developed areas. Cross cultural AI design, designing AI that respects different cultures. Humanitarian applications, AI helping in disaster response and aid. This is very, very important. Very, very, very important. Very, very, very important. Many should work in this area. AI methodologies, algorithm design, creating step by step instructions for tasks, statistical learning theory, how machines learn patterns from data, computational learning theory, understanding the limits of what machines can learn, and Bayesian inference, updating beliefs based on new evidence, optimization techniques, methods to find the best solutions. So, optimization, Bayesian inference, statistical learning, and algorithm design. So, that's all. The end of the lecture series. This was the last lecture of overview, simple overview of artificial intelligence. Thank you very much.